Hello and welcome back to this course on programming in Rust. So in this video, we're going to be building our next project, a real command line tool called word tally. Essentially, we'll point it at a text file and the tool will tell us which words show up the most often. It's a simple project, but it's going to be really useful because it pulls together nearly everything that we've built up so far all into one project. And this includes reading command line arguments, reading a file, counting with a hash map, splitting code into modules, handling errors the proper way, and putting iterators and closures to work. So this is what the tool's going to do. Essentially, it's going to read a file or give it a file path and optionally a number for how many of the top words you want to see. It's going to read that file and then break it into words, count how often each one turns up, and then print the most common. And we're going to lay this out in the real way that Rust projects are laid out. So we're going to have logic living in a library with just a thin wrapper in main. Every error will get handled properly, so the program is very defensive, and if anything falls over, we can use errors and handle those errors properly. So in my file explorer, I've already created a new project called word tally, and I've also got a books.txt file. This is the Art of War, which I've gotten from the Project Gutenberg website. So this will be the file that we'll work with in this project. So actually, I'll open up the main.rs file. Now, a program that reads its command line arguments through a function called std, : env : args. So in this main rs file, we're going to clear out the hello world sample code, and we're going to write the following. All right, let me open up the terminal. Just clear that, see where I am. There we go, I'm in the word tally directory. Go cargo run --book.txt. Now here's a little gotcha that you need to kind of be aware of early. The very first argument, index 0, will always be the program's name, not anything that you type. So the file path that you actually care about lands at index 1, hence using the 1 here. And when you want to pass an argument through cargo, you put a double dash first. So if I just highlight that, then your argument. The double dash is essentially how you tell cargo everything after this is for my program, not for the cargo itself. This little main is just really a stepping stone to kind of so you can see how arguments work. So in a moment, we're going to hand over the argument reading over to a proper config type, and then everything from there will live in a library. So here's a structural idea that matters a lot in real Rust projects. Keep main really thin and put the actual logic in a library file that's easy to test and reuse. So we'll go into our file explorer. I'll get out of the terminal for now. And next to our main rs file, I'm going to create a file called librs. Everything from here is going to live in this file. First up, we're going to create our settings. So reaching into that argument vector by indexing all over the place will get fragile really fast. So instead, we're going to gather everything into one tidy struct called config, with a builder that reads the arguments and checks them as it goes. So let's write the following. Okay, so a lot of what we've learned is kind of working together here. So this public function build takes an iterator of strings, and that's what the implement iterator item equals string, that's what that means. We don't care what kind of iterator it is, as long as it hands us strings. Next, we call to pull in each argument off in turn, and we'll do some pattern matching. So this match here handles its missing case safely. Ownership matters here too, so each string moves straight out of the iterator and into the config, so there's no copying. That's what this args next is doing with nothing done to its result. It just throws away the program name at index 0, and the build hands us back that result. So this is error handling at work. A finished config, or a short message to say that if something's wrong, we're going to tell you what's wrong. The top field defaults to at least 10. That's what that none is doing. And if the user does pass a number, parse will turn it into a 1 with the question, will turn it into a number, with the question mark following any parse error out. And this min-len reads an environment variable. So this is a very tidy way to let someone ignore short words without changing the command. Right, now let's move on to the heart of the tool, which is counting. And this is where iterators and closures really come into play. So in one chain, we're going to split the text into words, tidy each one up, and then drop the ones that are too short, and then fold the rest into a hash map of counts. So for this, I'm going to add a using statement. So we can use our hash map. And then underneath this implementation of config, we're going to write 2 functions like so. So let's read our 2 functions from top to bottom. So essentially with count words, we're going to split the text into words, normalize each one. So this is a little helper that we've created to lowercase our text and then keeps only the letter and digits. And we're going to keep the ones that are long enough and then fold them, let me just highlight this, into a hash map. So adding 1 for each word. And notice that normalize is its own tidy iterator chain too, with a closure inside the filter. Now, fold is just a way of boiling a whole sequence down into a single value. You give it a starting point, which is an empty map, and a closure. And it carries through that map through every item, updating it and handing it on to the next item. Then that entry or insert pair that we're doing on line 39 is the standard hash map move. So entry hands us the slot for a word, or insert drops a 0 in if it's new. And then the star out at the front essentially follows the pointer to add 1 to it. So a hash map has no order to it at all. So the pairs are going to come out however they please. So to show a top 10, we're going to tip every word and count pair into a vector and then sort it by count with the biggest first. We break ties alphabetically, so the output comes out the same every run instead of shuffling around. So below this normalize function, we're going to add this rank function as follows. Okay, so we use an iterator to turn the map into a vector of pairs and then sort by count, highest first, with that sort by taking in a closure. Comparing B's count to A counts rather than A to B is the trick that's going to give us the highest value first. And then at the end is the tiebreaker. So when the 2 counts are equal, we fall back into comparing the words alphabetically. Finally, we take the top and then collect pulls just the first however many entries into a fresh vector. So now we're going to tie the pieces together in a run function and then put it into our main function back in main.rs. So run is essentially going to read the file, it's going to do its counts, its ranking, and then print. At the top of this file here, we need to add a couple of using statements. So as follows. And then underneath the implements config here, we're going to create that run function as follows. Okay, so our run function returns box dyn error, and that's traits showing up again. So a trait object just means any type that implements the error trait fits here. So every different kind of failure, so a missing file, a bad number, can share one return type. And this question mark here on the read to string function is error handling again. So forwarding a read error up and out instead of crashing. Now let's go back into our main file and we'll get rid of this code. And what we'll do is we're going to actually implement our run function that we've just written in the library. So let's write the following. So because our logic lives in our library crate now, main will reach for it by package name. So this word tally : config. And we can access the run through word tally : run. Notice how we're passing the environment argument straight into build with no vector, no indexing. The iterator goes right in. So unwrap or else will take a closure. So closures will let us handle the error ourselves instead of crashing. And we print a message saying there's going to be a problem passing arguments, and then an exit with a non-zero status, which is the standard way of a program saying something went wrong. Now this print line here with the extra E will write this to standard error, which keeps error messages out of any results someone's piping onward. And if that let on run pattern, this is actually doing the same as well, this print line. So for errors that crop up while the tool's running, this is how you handle them. Okay, so I'm going to open up my terminal. Just get some more real estate going. Let me clear this. And let's run our project. So cargo run -- book.text. And let's take the top 5. And there we go. So we can see that the appears quite often in this book, so 3,675 times. And these are some real common words, so off, to, and in. And we've got the word count of how many times they're appearing, and the actual word that's appearing. So it's working. So we've managed to get something working, which is pretty good. But as you recall from our testing lesson, we know this is not good enough. We have to actually test our code to make sure that it's going to run as expected. Now, because our logic lives in the library, let me just get out the terminal. Testing is easy. And we've already got a whole testing toolkit that we covered earlier, which is the test attribute with the config test module and also assert macro. So I'm at the bottom of the lib.rs file. And we're going to add a test module covering the 2 functions that do the real work. So let's write the following. Okay, so I'll open up my terminal and I'll clear this. And we can run our tests using cargo test. So our 2 tests have passed. So let's have a look at these. So get out of the terminal. Now the first test pins down the counting. Words get lowercase and stripped of pronunciation, or punctuation, sorry, not pronunciation, before they're tallied. So cat and cat in uppercase count as the very same word. The second checks that ranking sorts by count and keeps only the top view, so this rank orders by count and limits. And here's why these matter right now. We're about to add a whole new feature, and these 2 tests are what let us do it without worrying that we're going to break something. If they still pass afterwards, we know we haven't broken the counting logic that we've already implemented. So our tool reads 1 file, but now let's expand it a little bit to make it read from a whole folder. So if I open up my file directory, I've got a whole bunch of text files within this samples file, and then a subfolder called notes and another text file there. Just close that back up. So essentially, we're going to make or expand our tool to read this whole folder and every file underneath a path, and then we're going to tally all of that into one combined count. We're going to write a function that takes a path and a shared totals map. So if the path is a single file, it adds that file's words in. But if it's in a folder, it steps inside and calls itself on everything it finds. So above our tests and under our rank function, Actually, before we do that, we need to scroll right up to the top and add this using statement so we can actually navigate paths. Now, underneath our ranking function, let's write the following. Okay, so this path is directory asks a simple question. Is this a folder? If it is, the read directory will list what's inside. And for every entry, we call tally path on it again. And that calling itself is the recursion, which what lets us go all the way down through the nested folders without ever knowing how deep they run. If it's a file instead, we try to read it as text and then work out what it works out is that we merge its counts into the totals. And notice that we quietly skip anything that isn't valid text. That if let OK is a bit of pattern matching that lets the tool walk straight past a binary file. So this is an image, for example, without the application crashing. And the return type is an IO result. So error handling is here too. And the question mark will forward any file system failures back up to us. Okay, so I'll go back up into the run function in the lib.rs file. And we're just going to get rid of this and rewrite our function to the following. All right, let me open up a terminal. I'll use our original one and I'm just going to clear that. Let's run our tests first to make sure they still pass. Cool, so our tests still pass. Our refactor hasn't broken our core logic, which is good. This is what we like to see. Let me clear that again. And I'm gonna run -- I'll go into the samples and we'll look for the top 5 words. And there we go. So our test still passed. The counting that we've built and tested has been untouched. And now the tool ranks words across a whole directory tree. So rather than just a single file, we can now go walk through an entire directory tree and perform our word count and ranking, which is really awesome. All right, congratulations. You have just built a command line tool in Rust. You should be very happy with yourself. Pat yourself on the back. But before we finish up, let's recap what we covered in this video. So we can read arguments into a config. So we can take the arguments iterator straight into a config struct and check that it makes sense before we do any work. We also learned how to keep the main thin and put logic in the library or in a library file. So your main function actually just wires things up. The real work would live in a library file, which we called lib.rs, which makes it easier to test. We performed some counts with an iterator and stored into a HashMap. We looked at how one chain splits, normalizes, filters, and folds every word into a map of counts. We also did some ranking with a vector, so we tipped the pairs into a vector and sorted by counts, biggest first, breaking ties alphabetically so we made sure that the output was stable. We also learned that errors return a box dyn error, which go to standard error. So one boxed type covers every kind of failure, and we use standard error messages to keep those messages out of the piped output. We also did a bit of recursion through directory walking, so the tool now steps into subfolders by calling itself on each one, counting files and exploring folders all the way down the tree. And we also learned the value of tests, how we can use tests to let us add features safely. So non-text files in our case will get skipped instead of crashing. And because our test still passed, we could add directory walking knowing that we hadn't broken our counting logic. So that's our word tally project built end to end. Next up, we're going to head back into concepts by covering smart pointers. So if you like this video, give it a like. If you're enjoying the series and want to see more videos on Rust, don't forget to subscribe. Any questions, please pop them in the comments section below, and the code for this lesson will be on my GitHub, which will be included in the resources in the video description. Thank you so much for joining, and I'll see you in the next one.